Welcome to Study Loop.
This is the answer to Chapter 23, problem number 61 from the Smith Organic Chemistry textbook. This problem says treatment of alpha-beta unsaturated carbonyl compound X with base forms the diastereomer Y. Write a stepwise mechanism for this reaction. Explain why one stereogenic center changes configuration, but the other does not. Okay, and so one thing to note off the bat, these are both gamma protons. And so we expect them to be acidic, or pardon me, these are both gamma carbons. And so we expect any protons on those carbons to be acidic. But the reason that this top stereocenter does not equilibrate is because there are no protons here. This carbon has 4 bonds to other carbons. And so since there are no protons, it can't be deprotonated. And since this mechanism is basically deprotonation and reprotonation, obviously it can't participate in that reaction. It has no proton to be deprotonated. So that's why that stereocenter does not change at all. As far as the mechanism by which the other one changes, so that is going to look like this. So this proton will be grabbed by the base. These electrons will go here. And so now, after the first step, we have a planar carbocation here, a planar carbanion. And so we have our lone pair and negative charge, and we have the methyl group there that's not, it doesn't have stereochemistry since this is planar at this point. And one thing to keep in mind is the reason that these gamma protons are so acidic is because they the conjugate base made by deprotonating them is resonance stabilized. And so here are the resonance structures that show that, which the problem didn't strictly ask for, but is a good thing to include. And certainly if anybody needs a review of why these protons are so acidic, this is why. So we have these 2 resonance structures, one of which places the negative charge that is generated on electronegative oxygen. So that's good. We always want charges on electronegative atoms. So this is a pretty resonance stabilized conjugate base here, and that's why those protons are so acidic. And then for the last step of the mechanism, water is just going to reprotonate where we just deprotonated. And that protonation can occur from either face. So it can come from behind or below, which will just reform our starting material, X. And I guess I should label this X since the problem does. So this is X, and then over here, this will be Y. So we can reform X, but we will also form some Y, which is the opposite diastereomer. And so obviously over time, we should end up with a 50-50 mixture, since either of these protonations is just as likely as the other to occur. We should over time get, equal parts of each. But yeah, so the protonation can occur from the front or the back. And so when it occurs from the back, when it occurs from the front or above, however you think of it, we end up with this other diastereomer Y. Okay, and so that is why the one methyl group doesn't equilibrate, and that is the stepwise mechanism for the equilibration of the methyl group that does isomerize or equilibrate. And that is the answer to Chapter 23, problem number 61.